So we're going to talk about trigonometric integrals of this form in this video. So trigonometric integrals make their own series. So this isn't trig substitution, this is trigonometric integrals. So I'm going to talk about integrals that are of this format where you have different powers of sine and cosine. So this will be just this video. I have a second video where I talk about these two topics, and then I have a third video where I just talk about this topic. So I just wanted to make sure I've laid out kind of the plan here. So we're going to just only talk about different powers of sine and cosine. And so this is going to be a little tricky. So there's a couple different cases here. So the first case is, what do we do when m is odd? So when m is odd, what we're going to do is we can rewrite m so that we can rewrite it in its like odd number form. So we call this 2k plus 1 form. So basically you just rewrite the odd number like this. So I'll show you an example in a second. But the reason why we want to think about it in this 2k plus 1 form is then we use exponent rules to break this up. So m now equals this 2k plus 1. And so then what I'm going to do is I'm going to have sine squared and then this to the kth power. So this will be 2 times k, and then here's an extra sign, so then there's your plus 1. So this is equivalent to this. And now in setting this up, what I can do is I can take my sine squared x, and I can use the fact that sine squared x equals 1 minus cosine squared, and then I can finish integrating. So I think it'd be easiest now, I've kind of shown you the game plan, so I'm going to show you now how do we actually do this in an integral, okay? So the integral that I'm going to use here is going to be sine cubed 4x cosine squared 4x dx. All right, so in this case, my sine is odd, right? And so if I want to write 3 in that 2k plus 1 form, so it's just 3 can be rewritten as 2 times 1 plus 1, right? So this just has to flip back to 3. So you think of what is the largest even number just before that, you can then multiply that together and then add 1 to it. So this is how I now want to guide my breakup of the sine cubed. So I'm going to have sine cubed is going to be rewritten as just sine squared times sine to the 4th. So this is 2 plus 1, that gets us back to the 3. So we're trying to just strategically break up our trig function. Okay, so from here, now what I'm going to do is I'm going to make this replacement, but I'm also going to take my sine squared to the 4x. So now I'm going to use that property where this is going to be written as 1 minus cosine squared 4x. So this part here has been replaced, and then I still have this sine to the 4x here, and then I'm also bringing this back into the integral, so I've got this cosine squared part here. Okay, so at this point, pause and look at everything that we have, okay? Previously, this would have been impossible to integrate, no way to do it. But now I have all the pieces here of how to finish integrating this. And I would challenge you at this point to see if you can just finish the integration, because you should be able to finish this by using just substitution. So pause here and give it a try. So what I'm going to do is you kind of have to be strategic now in how you multiply this together. So what I'm going to do is I'm going to take this cosine squared and I'm going to distribute it into just this set of parentheses. So if I distribute this part into this set of parentheses, this becomes 1 times cosine squared, so that's cosine squared 4x, and then cosine squared 4x times cosine squared 4x will give me cosine to the 4th 4x, and then I still have this sine 4x here. So now I can use substitution. So I can set my u equal to 4x, so that means my du will be negative 4 sine 4x, and I can rearrange that as seen here. And let me give myself some more space. Okay, so now I'm going to go ahead and set up the rest of this integral, right? So this becomes, so this negative 1/4, I'll just put it on the outside of the integral here. But now this cosine squared becomes u squared, this cosine to the 4th becomes u to the 4th, and then I've got my du, bada bing, bada boom. And so then I just integrate, and so I have, I can integrate this no problem, and then I can just go ahead and replace my u as you see here, and so then we're all good to go. And I also distributed my negative 1/4. So that's the idea then when sine is odd. And so if we just flip to the other possibility where n is odd, so when n is odd, we're really going to just use a similar procedure here. So we'll still write n in that 2k plus 1 form, and then we can split up this cosine into cosine squared to the k times cosine x. and then rewrite this now as 1 minus sine squared k, or sine squared x to the k. So let's just take a look at an example of this. So for instance, let's say that I have cosine cubed 2x. Okay, so for this one, so again, just to break up that cosine cubed, so I'm going to rewrite this as cosine squared 2x and then just cosine x. So I have 1, 2, and then 3 cosines to get my cosine cube. So it's still equivalent, right? And then I will rewrite cosine squared as this 1 minus sine squared 2x times cosine of 2x. Now, once again, I'm just going to suggest here that you finish this on your own just to make sure that you've got it, and then hit play when you're ready. Like I always say, math is not a spectator sport. You'll get more out of this if you try it. Okay, so I'm just going to go through the solution here. So we're going to use substitution again. So in this case, my u, I'm going to set my u equal to sine 2x, and then my du will be this 2 cosine 2x dx. I guess you also could have just set this as 1. No, it has to be sine 2x. Never mind. I thought that wasn't correct. So anyways, so now I can rewrite the integral as you see here. So I have this extra factor of 1/2. I'll just bring it out in front. And then this is 1 minus u squared du. And so then I can go ahead and I can just integrate this. And so this will be 1/2 times u minus 1/3 u cubed plus c. And then I can go ahead and distribute that 1/2 and replace u with sine 2x. And so we get the function that you see here in this case. So the last case that I want to talk about then is what do you do if both m and n are even? So if they're odd, you have some like flexibility as to like how you can kind of wiggle with these. If they're both even though, then you need to use a totally different identity. So in this case, we're going to use these two identities that you see here. So sine squared x equals 1 minus cosine 2x over 2. And then cosine squared equals 1 plus cosine 2x over 2. So these are two very vital identities that you really should know for any calculus class. So this is like right up there with like the Pythagorean identities. You could bust these out at any time. It just depends on the context, right? So, all right, so let's say I have this situation here. So I have sine to the 4th x cosine squared x dx. So one of the other things that you want to do is, so in the event, so this is not sine squared, right? This is sine to the 4th. So once again, we do want to leverage that sine squared format so that I can actually use this identity. So the first thing that I'm going to do is I'm going to rewrite sine to the 4th x as sine squared squared. So this is equivalent, right, to sine to the 4th x, but now that I have this as sine squared x, now I can leverage that identity. Okay, so from here, now I'm just going to replace sine squared x and cosine squared x. I'm going to replace both of them with these two identities here. So it's going to look like this. So now take a look at what we've got here. I've got 1 minus cosine 2x over 2. This has to be squared, and then I have just 1 plus cosine 2x over 2. So this is going to require a little bit of work, and I think that this would be a really good one to try to see through, because we've talked all about how to kind of approach these now. So there's going to be some multiplying and some simplifying and some collecting of like terms and some integrating. This is a challenging one. This is a good one to challenge yourself with. So let's see how you're doing at this point. You know, the worst that happens is you make a mistake and you'll learn something from it. That's not a real problem, right? That's a good thing. So let's just challenge yourself. Let's see where you land, and maybe you'll surprise yourself. So pause here, hit play when you're ready. All right, so let's break this down. So we're going to do this piece by piece. So first things first, I'm just going to square the bottom portions so this is 2 squared, so that's 4, and then obviously this won't be squared. So then this will allow me to take out this constant of this 2 times 4, so I can bring 1/8 out. So I'm going to go ahead and do that, okay? So that leaves me with 1 minus cosine 2x squared and then 1 plus cosine 2x. So this I can FOIL out. So let's do that. So I'm going to FOIL this part out here. So I get 1 minus 2 cosine 2x plus cosine squared 2x, and then still I have to multiply by this. So now I have to multiply all of this together. So first thing I would check for in how you've done your work is that you have all of these terms. And from here, because if you miss any of these terms, right, then the rest of the problem is going to be wrong. Now from here, we need to collect our like terms. So I'll make some space. So I go through and I just collect my like terms. And so I'm left with 1 minus cosine 2x, because I have positive cosine 2x minus 2 cosine x. And then I have negative cosine squared 2x, because again, I have negative 2 cosine squared plus cosine squared, so that makes negative. And then plus cosine cubed 2x. All right, so now, and now you're kind of seeing also like how these problems can kind of explode and get kind of tricky. So now I have to look through this whole integral and kind of decide like what can I do next. So I always first look for what can I immediately integrate. So this part here can be easily integrated right now. The rest of this is going to take some work, okay? So let's go ahead then and work through this. So first I'm going to integrate this part. So this is going to be x minus 1/2 sine 2x. So this green part is done, and these are the other two integrals. So I'm just breaking these up into two separate integrals so that we can divide and conquer the rest of it. So we'll start with this integral here first. So once again, you know, I don't know how far you got with the integral, but if you haven't tried to like finish integrating this, if you got stuck, I would say now would be a really good point to try to finish this totally on your own, just so you can like try to find some confidence. And again, if you make a mistake, there's no problem here, right? Like it's just you versus you. Give it a try. Try to finish the whole thing. Hit play when you're ready. Okay, so I'm starting with this integral here. So the only way to integrate this is again by using that half angle formula. So I can now rewrite this as 1 plus cosine 4x over 2. Now keep in mind, I just want to remind you of the formula one more time. So the original formula was cosine squared x, and then this was 2x here. So since now I have cosine squared 2x, I need to take that 2 and multiply it by 2 here. So I do just want to like double check that you actually have that this is 1 plus cosine 4x here, okay? And from here, the rest of this can now just be straight up integrated. So I can go ahead and integrate. So I'll break this into two separate fractions. So this is 1/2 x, and then this becomes 1/8 sine 4x, and then I need to just multiply by that negative 1/8 to get what you see here. Okay, so now this blue part that we were just trying to integrate, now I can fill that in for what that answer is. So this was minus 1/16 x minus 1/64 sine 4x. And so now we can work on this part. And we just did a very similar integral for this, right? So we know how to evaluate this. So now I've got 1/8 cosine cubed 2x. So what I'm going to do is I'm going to break up that cosine cubed into cosine squared and cosine. And then I can go ahead and switch the cosine squared into this 1 minus sine squared 2x. And from here, now we can use substitution again. So my u will be sine 2x, my du will be 2 cosine 2x, and then I have to just rearrange this so that I can actually substitute. So in substituting this, I have this 1/8 now. I brought the 1/2 constant from the du, I brought it out in front. This is the integral that I am left with. And so then from here, I can just finish my integrating and I can plug my u back in. So I have 1/16 sine 2x minus 1/48 sine cubed 2x. Okay, so now I can go back here and I can fill in the last part of this integral. So I'm just going to put everything here. And so then from here, I can, of course, collect my like terms. So those 1/16 sine 2x's will drop out. And so I am left with the answer that you see here when you collect all of your like terms. And okay, so that brings us to the end of that one. Good times. Just as a reminder, I do have other videos if you want to see more examples. And otherwise, I'm going to leave it at that. I'll talk to you guys in another video. Bye.